All right, I see we got Elizabeth on the line here, and Stephen and Sonia. So one of the great features that's happened to us on our interface here through Canvas is they're constantly making upgrades. And now I don't have to do a screenshot of you folks. I can actually see who was here from my different Zoom controls in Confer Zoom. So that's a neat feature that they've just added on. So if you come in and spend time with us, you get credit. I have you on record now. It has an attendance record, which is fantastic. So again, great job being here, and you guys will get extra credit for doing so. Now, I wanted to jump over to modules and start with that because you know, I keep adding content to your class, and it's one of these things where, you know, I know this isn't a huge class, but man, when you get into electrical, there's just so much to do. So last week we were going through some of this information on week 4. I actually decided to break out the presentation that I was using and kind of split that up a little bit better. So I modified this a little bit. The only homework you had to do was just basically do a little discussion on your meter, and a lot of you guys have already done that. We did some demonstration on doing some bench work with testing relays and stuff, and talked about voltage drop testing. Here we are in week 5, and you'll see that I have different presentations that I have loaded up from the battery starting and charging system diagnostics. We won't be able to hit everything, right? I try to keep you here no more than an hour, but we're going to hit some of these highlights, and the video clip I put together relates to this as well. We also have some AC voltage testing, and then I started to mix in some advanced features on a meter such as the Fluke 87 or 88 and the Snap-on, where it would have min, max, and some of those other things. So stuff's constantly, you know, updating and improving. After class tonight and tomorrow, I'll get week 6 information updated and get some more stuff loaded on in there. I think we'll end up with a lot more content than I can possibly cover, but I want you guys to have access to everything. So with that, let's jump in to some of these presentations here with the batteries, starters, and alternators. And we'll change the screen share and start moving forward on that. All right, new share, and I'm going to go to batteries. Okay. Well, this presentation's rather big. I guess I should have started at the beginning. Some of this stuff is basic, right? Like here we're focusing on lead acid batteries, and like I've told you a bunch of times, you diagnose a lot of things from a good thorough visual inspection. There's a note here on radio, memory locks and memory savers that you can use that are always a great idea. Heat shields. Man, I've seen some ugly stuff on batteries, and that was one of them. So corroded connections. Remember, this can lead to a voltage drop issue, right? But let's get to, there's another, the side posts that General Motors likes to use are really common to have problems. So underneath these side posts, it's not uncommon to find corrosion, which will give you that voltage drop issue. So check those guys. Of course, baking soda and water. A lot of battery manufacturers, they don't even want you to pop the caps. I still like to pop them if I can to see in there. Obviously, in this case, the electrolyte levels below the plates, I know that that battery's done. I mean, maybe I could add distilled water and bring it back, but if this was my customer's car, I would just be recommending a new battery. And what I would be doing here is I'd be checking the charging system to make sure that the charging system is not overcharging the battery, and that is why the electrolyte boiled out of there. Okay. Moving right along, state of charge. We've gone through this one before. I'll talk about it again. That guy's sitting at 12.78 because, as we talked about last week, it has a little bit of a surface charge on the battery. We know that a fully charged battery sits at 12.6 volts, right? So if you're over that, there's probably a little bit of a surface charge. Turn the headlights on for 30 seconds, turn them back off, and see where you're at then. So this is where you should be. And again, if your battery's sitting at, let's say 12 volts, well, it's really only at a 50% state of charge when I'm sitting here at 12 volts. All right, so that's our very first test, is see what is your state of charge, right? Because even if we think about Ohm's law, and I'll draw my classic Ohm's law pie chart over here with volts, amps, and ohms, right? We know that these three guys are all related. And if, let's say, the resistance would go down, the amperage would go up, right? But if I don't have any voltage, if I don't have any electrical pressure from the battery, everything's over, right? If the volts drop, both of these drop. Like, I just can't, that's where you want to start. I've had many cases where I had a car that had a weird drivability issue. I've even had cars that were failing smog, and the fix was to replace the battery. All right. So don't overlook battery state of charge. I guess I should mention this. A lot of the AC Delco batteries had this little green eye. That was like a hydrometer that only went to one cell. So it did a good job telling you what was going on in that one cell, but there's 6 other cells in the battery. So you could have a battery with a dead cell that didn't happen to have the one with the eye in it, and the eye would indicate everything was okay. So I didn't find those to be really all that useful. Okay, so we've done our open circuit voltage testing. And then I do have some notes here on leakage. If the top of your battery was really wet, like, oh, where was it? Like this one. See how this top of this battery is all wet? You're very likely to have the battery self-discharge from the wetness on top of the battery. And again, that's another sign that the battery has been overcharged, probably an overactive charging system for some reason. It does also happen in really hot weather, even when everything's normal sometimes. So if you thought you had a battery that was sitting there and it was going dead, this particular procedure where you put the lead on the plastic part of the case and the other lead is on a terminal, okay? Here it is on the negative terminal. That's gonna let you know, am I basically discharging through the case of the battery, which can happen. It usually only happens though when you have a battery that's really wet, dirty, and nasty, okay? My rule is if the battery looks dirty, like clean that thing up. Baking soda and water on the terminals, simple green or something, and wipe down the plastic casing, but get that battery clean. A clean battery is a happy battery. All right, so that's what that test is about. And I'll keep moving forward. There are some other tests you can do, like the 3-minute charge test. In order to do this particular test, you need 2 things. You need your digital multimeter, and you need one of these battery chargers that has a fast charge feature, because you have to start at a charge of 40 amps. You have to basically try to ram a bunch of amps into the battery and see how it handles that charge. What's important here though is that you can only do this test when the battery starts off being discharged. So if you walk over to the battery and you measure the battery state of charge, and let's say you walk over the battery and it's sitting at 12.6 volts, well, I can't do a 3-minute charge test then because the battery's already fully charged. So that's not going to work. But if you walk up to the battery and it's sitting at 12.3 volts, well, this is a great test to do then, because you know the battery's already discharged a little bit. It has room to be charged. So I'll hook up my 3-minute charge. I'll hook up my battery charger. I'll charge them for 3 minutes. And at the end of 3 minutes, I'm going to just see what the battery's voltage is. It's a really easy test to do. Oops, if I get my mouse going the right way. So at the end of 3 minutes, I want to see that the voltage is 15.5 volts or less, okay? And that tells me, okay, that battery is not sulfated. If I walk up and the voltage is sitting at, let's say, 16, and I've seen them sitting at 17, 18, 19 volts, then that means the battery is sulfated and it's not taking that charge. Now, what causes a battery to sulfate? When a battery sits around discharging and the battery plates get hardened. Remember that a battery, if I go forward, sorry guys, I should have had this sooner. Inside a battery is a bunch of plates, right? Plates that have lead peroxide on them and sponge lead. So you have two different types of lead in the presence of H2SO4, or basically sulfuric acid and water mixed together. And so if the plates are sulfated or crystallized, it's hard to reverse the chemical reaction that happens in the battery. So the battery becomes hard to charge, and it also then discharges very quickly. So that's what we mean when the battery is sulfated. It means that the plates become lead sulfate, or PbSO4, instead of being sponge lead or Pb and lead peroxide, PbO2. Anyways, the chemical reaction in the battery has slowed down. So what you're doing with the 3-minute charge test, and I'll get out of presentation mode here. What you're trying to do with that 3-minute charge test is basically see, well, the battery is discharged. How easily does it take a charge? A good battery will take a charge very easily. It'll be hungry to take that charge. A battery that is going bad, that is sulfated on the inside, the lead on the plates has begun to crystallize, it will not accept that charge. And that is why the voltage will raise well above 15.5 volts, okay? So that's the 3-minute charge test. But simpler than even that test, I mean, that's a great test to do. If you walk up, you measure the state of charge of the battery, and it's below 12.6 volt, then I will jump into a 3-minute charge test. But if I walk up to the battery and the battery voltage is 12.6, well, then I'm not going to do a 3-minute charge test. What I'm going to do is I'm going to crank over the engine and see what happens then. So let me fast forward to that. I'm skipping some of these with the heavy load testing because not too many people have a VAT 40 or VAT 60 in that picture sitting at home. So I'm going to skip it. And what I'm going to get to, and you know, maybe some of you guys might have a Midtronics tester, or you could go to O'Reilly's or AutoZone and they're going to have a tester similar to this or this that they could test your battery with, and that's fine as well. But I'm going to skip that guy as well because we're focusing on what you can do with your meter. And so I like to call that available voltage. I've walked up, the battery sitting here at 12.6 volts. Looks good. You can see that my alligator clips here are on the positive and negative terminals, right? And I'm going to start cranking this thing over. And when I do that, the battery voltage is going to drop down. Now, ideally, when the battery voltage drops down, ideally, I would like the voltage to be above 10.5 volts cranking. Why? Got a U in there. For the computers, the computers typically want to see 10.5 volts or more so that they can function and do their stuff and get the car started properly. Okay? Questions on any of this stuff? Remember, you can type a question in the chat. I got my chat box up. Even if you guys can't see it on your screens, I can see it on my screen. Click that option to bring that chat box up if you want to do that. I've had a few students and they say, hey, I hate the sound of my voice on the Zoom call. So that's why we have that option. So I'm going to crank it over with my voltmeter hooked up to the battery, and I just want to see what the voltage is cranking. Ideally, I'd want to crank it over between 10 and 15 seconds. I don't really want to crank over a starter longer than 15 seconds. Your starter is a high torque, high output electric motor that's made for short intervals. If you crank it over for 30, 45 seconds, you'll actually overheat that starter and you could cook the insulation off the windings, cook the grease out of the bearings and bushings. So you really don't want to crank and crank and crank and crank on your starter because you can overheat it and ruin it that way. In fact, oftentimes you would see somebody, they get a drivability problem with their car. Their car, the fuel pump's starting to take a nosedive, right? It's a Chevy, Ford, or Dodge, and it's got 100,000 miles on it. You basically know that it's going to need a fuel pump, right? So it starts, the fuel pump starts crapping out, and they start cranking it more and more and more and more and more to get it started. And then by the time it comes into you, it needs both a fuel pump and a starter now because they've roasted the starter from all the successive cranking. So I try not to crank it more than 15 seconds at a time, and then I'll make sure I let it, you know, sit and kind of cool for a while before I crank it up again. All right, so moving right along, where we went from 1267 down to 10 volts. So at the battery, we were at 1267. When we started cranking it over, it dropped down to 1076. And actually my picture, I actually went down and put my lead right at the starter and saw what it was right there. But actually on the battery terminals, and I guess it was hard to see from that, but one thing you'll notice if I back this up, one thing you'll notice here is that, see how my positive lead is no longer on here? I actually moved them down to the starter when I took this screenshot, and I forgot to take the screenshot of the lead being up here. So the starter itself had 10.12 volts going to it. However, at the battery, we had 10.76, which is above 10.5. So the computer systems would have read 10.76 volts. They should have been happy, and this thing would be a pass for its available voltage. We also, because I went from the positive battery post down to the starter motor, you can see we had a difference of those two of 0.64 volts, which tells me I'm dropping 0.64 volts across the positive side of my starting circuit, which, you know, I would like it to be less than a half a volt ideally. A lot of cars, they're okay as long as they're below 1 volt, that is within that window. The other thing you got to ask yourself, here's the big question, guys. Here's the big question to ask yourself is, how is it cranking? I am crank. Let's try it one more time. C-R-A-N-K-I-N-G. How is it cranking, right? If it's fast, if it's cranking over quickly, I'm happy, right? I really, you know, only would be concerned if I had a slow crank or no crank. Then I start thinking, oh, okay, well, there's something going on with either the battery not being able to supply the amount of amps the starter needs, or the starter pulling too many amps, or the last possibility is too much resistance in the starting circuit, right? So there's three variables there. And again, to kind of explain that and say those variables out loud again, if I got a nice spot here, the Ohm's law pie chart here, volts, amps, ohms. Here's one way to look at this, right? When you're cranking over an engine, that's going to take quite a few amps. In fact, let me put another impromptu little chart up here. You know, if I had a 4-cylinder, I might expect 90 amps being pulled from the battery, anywhere to maybe 135 or so amps. If I had a 6-cylinder, you know, I would expect somewhere maybe on a low side of 115 to maybe 75. If I have a V8 or an 8-cylinder, right, every cylinder is going to have more friction to it. So I'm expecting now more draw, right? So when we go to crank over our car, it's going to be pulling a fair amount of amps, right? On the low side, maybe 90 amps are going to be asked to flow out of that battery. Well, obviously, if the battery voltage drops as I'm cranking, that means that's going to drop, and that's going to hurt how many amps can then flow through the circuit, right? And because the battery itself is a electrochemical device, right? It's going to, that chemical reaction inside the battery is what creates the electrical pressure. If the battery itself is starting to deteriorate, its voltage will drop as you try to pull a lot of amps out of it, and you're going to end up with a slow crank, right? So as the voltage goes down, of course, the amperage is going to go down with it. Because if the resistance stays the same, both those go down, or voltage goes down, amperage is going to go down. Okay? Well, that would equal a slow crank. If the engine was physically hard to turn, where instead of it, let's say it's a little 4-cylinder and you expect it to pull somewhere between 90 to 135 amps, and it's pulling 200 amps from a little tiny battery for a 4-cylinder car, that's going to cause a slow crank because the engine's physically hard to turn, right? So another thing you could do for a slow cranking condition is you could always put a wrench on the engine and rotate it and see, well, how hard is it physically to crank over the engine? If the engine's really hard to move with the big 1/2-inch drive ratchet on there, well, maybe you have a mechanical problem that's making the engine extremely hard to turn over. So this could be related to the battery, but let me give you another example. I got a slow crank, and when I go to crank it over, it cranks slowly, but the voltage looks good. In fact, it looks great. It's actually above 10.76. It's like at 11.5 volts. Well, that tells me that the amperage is low. If the voltage is high, that means the resistance has to be high, and that would indicate too much voltage drop. So remember, you're doing these tests on the car. A lot of times you can think, oh, I'm not thinking Ohm's law right now. I'm not doing math problems. Ohm's law is always in effect on those electrical circuits that you're testing. So the available voltage is one I'll do quite often because it's super quick and easy to do. I'll crank over the engine and I'll see what the voltage drops down to. I've already saw what the state of charge was, right? I've done that open circuit voltage test at the battery terminals. I just keep them hooked up there and I crank it over and see what it drops down to. All right, let's clear out some of these drawings. This this little chart, I think I have it further on in this presentation, but those are pretty good numbers. Just remember this, if I have a bigger engine with more cylinders, they're going to have more friction, and I expect it to pull more amps from the engine, from the battery to crank over, right? Okay, let's clear that out. We'll keep going. Now here we're doing some voltage drop tests of battery cables to try to pinpoint exactly where we were losing that 0.67 volts. But the thing is if it cranked over nice and fast, I wouldn't concern me. If it didn't crank over at all or it cranked over slowly, that's where I would be concerned. I'm gonna skip past some of the specific gravity stuff. I kept it in the presentation so you guys know the information, but I'm gonna skip past some of that stuff because that's not something you're gonna do with just a typical multimeter. And quite frankly, a lot of battery companies these days, either the battery is completely sealed, so you can't do these tests, or they don't want you going in there anyways. I'm gonna bring up this test, parasitic draw. Why? Because it's a great test for our meter. It relates to a test that I believe Tom had asked us about before. So let's look at this one. So, parasitic draw. Now, what we're saying here is if I have a vehicle that has computers on it, those computer-controlled cars, the computers have memories. And to keep a memory going, that means that you're going to have some type of a draw. And that's just how it is. So I don't care if everything's perfect with the car. If I have, let's say, a 2004 whatever, and I let that thing sit for 2 months, it's going to kill the battery. A good example is my mother, when COVID came in, she didn't really go anywhere. And, for well over a month, almost 2 months, it seemed like she never even started her car. When she went to start it, of course, the battery was dead. Now that's a 1999 Lexus little SUV, an RX 300. Doesn't have a huge draw. I want to say the draw is maybe 15 milliamps, but that's still enough over that long of a period of time to drain down the battery enough where it won't start. What's our kind of basic rule? Well, to give us a pretty big range here, what we say is that, okay, 50 milliamps is what you can accept. If you get it below 50 milliamps, and keep in mind, you might have to wait quite a while for the computers to power down. If you wait over 60 minutes and you're still over 50 milliamps, you have a problem. If you're pulling like 1.2 amps, you have a problem. So how have we positioned our meter here to do this check? We would set it to amps, and when your meter is measuring amps, it has to be put in series with the circuit. Let me show you what I mean. Gotta clear out those drawings, get my mouse up. Okay, we are going to, I gotta clean up my screen here because I got so many different things up here. I'm gonna minimize the chat real quick. And I'm gonna do a new share. There we go. Okay, and we got the document camera up. And I have some stuff here for resistance testing for later. I have an inductive amp probe there. But what I want to get to is how do I set up a very basic meter for testing, right? For testing amps. Well, I'm going to move my positive probe to the amp's location. I would always start on the location that says, if I zoom in on this thing, that says the highest amp reading I could get out of that meter. In the case of this meter, it's 10 amps, right? So I'm going to move my probe over. I'm going to set this thing over here to 10, and then I would put my meter in series with that circuit, which means in order for this thing to measure amps, it basically has to have the electrons flowing through it on the inside from the red lead to the black lead. So to give you a good example, what I've done here is I have a test light hooked up to a battery below my bench, and I'm going to hook my test light up to the positive and negative terminals of my battery. And you can see with that, if I move them over, because it keeps kind of falling around there, my test light is on, right? We'll zoom out just a little bit. Okay. So if I want to know how many amps are flowing through this light, the meter actually has to be put in series with this light. So to do that, this is my jumper wire going to the positive battery terminal. My negative terminal is going to go to my light. And now as soon as I complete the circuit, right, the power flows through my meter. And when it flows through my meter from here to here, it gives me a reading. In this case, it's saying it's taking somewhere between, got a connection there, 150 and 160 milliamps, or 0.16 amps. So if I want a little bit better resolution, let me move this thing down. And I can see, okay. At this point, I'm going to have to move my meter lead. What you'll notice here on this meter is if I want to measure smaller amounts of current, that means I actually have to go move this back, because that's where I'm going to measure milliamps, right? So we know that we're around 150, 160 milliamps. Oh, I'm exceeding that range. Now we have a very exact reading, 158.6. So we picked up a little bit more resolution moving down to the smaller scale. Why would I always start on the higher scale, on the 10 amp scale? Well, because I don't know how big the draw is. And if I pull more than 10 amps through this meter, I blow my fuse in my meter like we talked about last week. And remember, these aren't normal auto fuses. They're like $10 fuses. So that would be frustrating, right? So always start on the 10 amp scale. Another thing I would do pretty commonly, especially on older cars, is instead of putting my meter in series, I would actually use this test light. We know that it takes, because we just measured it, 150, 160 milliamps for the test light to glow brightly, right? So what does that mean? Well, if I change my screen share here back to our presentation, what that means is if I replace this meter here, and instead I put my, I'm going to disconnect him, so I'm drawing an X over him. I'm going to put my test light, there it is right there. And I know it takes 160 milliamps to make that thing glow, right? So if I hook it up and this thing's glowing real bright, then I know this thing's pulling way more than 50 milliamps of draw because it's making the test light glow, and then we know that takes 160 milliamps. So especially on an older car that you know it doesn't have 20 computers in it that need to kind of power down, a test light works pretty well, and it's a way to kind of help you save your meter fuse. But when you want a more exact measurement, what you would have to do is physically, you know, risk the meter and put him in series, move the red lead over so that you're in series with the circuit. What you'll notice is I disconnected the negative battery terminal, so all the power for the car flows through the meter to make this test. And once I wait long enough, over time, the computers should shut down, okay? They should go down to a power saving mode. Almost think of sleep mode for your personal computer. And so because they do that, I'll exit out the document camera for a minute. Because they do that, once all the computers are asleep, we should be 50 milliamps or less. And oftentimes you'll see it start off and it's sitting there, it's got a 1 amp draw, then it's got a 500 milliamp draw, then it drops down to, you know, 200 milliamps and then 80 milliamps. As different computer memory circuits shut down, you'll see the power levels drop down. The more computers on the vehicle, the longer it can take to power down. It usually doesn't take more, though, than 60 minutes. Now, here's a tip. You got some smart keys and a key fob. Well, if you keep the smart key too close to the car, the computers will never power down and go to sleep because they're always thinking, hey, he's getting ready to go in the car and fire up. So it keeps everything awake, and that draw will kill your battery. So what do you do if you measure the draw and it's sitting here and I don't know, maybe it's 575 milliamps. So that's excessive, okay? And it doesn't go away. Well, now what you do is you go to your fuse panel and you start disconnecting fuses one at a time until you know, you see that draw vanish on there, right? When you pick the fuse where you pull the fuse out, the draw goes away. That's your circuit then that is causing the excessive draw. You just narrowed the field on the car, and now you have less area where you have to go digging, and you just start disconnecting things systematically to figure out what is causing that draw. I had a car where I start disconnecting fuses. It's got a high draw like this. I finally get to the radio fuse. I pull that radio fuse, draw goes away. Start disconnecting stuff. I actually end up having to pull the dash pad out. And when I reach back there and I pull out the wires to the back of the radio, I unplug the radio, draw goes away. So I know the draw is in my radio. So I call the customer and they're like, well, we wanted to put an aftermarket radio in it anyways. This was the stock one. I thought and they said, hey, can you take the radio out for us? So I unscrew the bezel. I go to take the radio out and I take it out and set it in my lap, and it makes noise. It makes a rattling noise. And I start shaking it. And what had happened is their kids were putting change in the CD slot. They were loading that thing up just like a slot machine. And so they kept sticking quarters and stuff in there until it created a short inside the radio, which was causing a draw to happen all the time. So you pull fuses and then you isolate the circuit and you systematically disconnect things, okay? That's how you find a parasitic draw. All right. Now the downside of using your meter, if you hooked up to a car and it had over a 10 amp draw, that would blow your meter fuse, right? If you had over a 10 amp draw, that would blow your meter fuse. One of the things you can do is if you notice when you disconnect, the battery cable here, let me get my drawing tool back up. If I go to disconnect this negative battery cable, and when I do, it lets out a hellacious arc as I disconnect it, that tells me I have a hellacious draw on this thing. If I don't see a big arc, I don't have that big of a draw, it's probably safe to use with my meter. But there is another way to do this, because whenever your meter is measuring amps, remember, it's in series with the circuit. In fact, I'm going to type that up. It's in series. When you're measuring amps. When you move that red lead over, you're in danger zone, okay? So you're likely to blow a fuse if you're not paying attention to what you're doing. So what's become popular over the last really 20 years is inductive amp clamps. So I couldn't find my low amp clamp tonight, but I did bring in my more high amp clamp. And to show you, I'll put this guy up on the document camera. Let's get this thing switched over. That pretty much kind of finishes this presentation and my tips and things. Come on, sir. So look for obvious problems. Oh, disconnect aftermarket equipment. If somebody put some crazy car stereo amplifier, disconnect that stupid thing right away. You know, easily 8 times out of 10, it's the aftermarket garbage that's your problem, okay? So I would obviously look for disconnect, obvious problems, disconnect aftermarket stuff, and it doesn't hurt, especially if the car might have charging system issues, disconnect the alternator. The alternator is hardwired to the battery. That could be causing a draw. So you disconnect that alternator, and if it's none of those things, you start pulling fuses one at a time. All right, let me show you that. Low amps pro, or sorry, amp clamp here. Get that document camera back up and working. There he goes. He's thinking about it. So this is a kind of an inexpensive one. It's a little PDI one. PDI used to have great deals on meters and stuff for students. You can't buy from them directly anymore. You got to go through AES Wave, and so it's not quite as good of a deal as it was. But what is this thing? Well, whenever you have current flowing through a wire, okay, it creates a magnetic field around that wire. So when current flows through that wire, magnetism is flowing around it. And this guy has the ability to pick up that magnetism. In fact, it tells you the polarity to put on there. So you put it on, it picks up that magnetism, okay? Has a little battery in the back, and you can see I've turned it on, the green light came on. So it basically picks up that magnetic field and then uses its little battery and turns that magnetic field that it senses into an electrical voltage signal that your voltmeter can measure. So if I happen to be using one of these clamps, what I would do is I would disconnect my leads from my meter, and I would then connect my amp clamp up. And one thing is, I don't know how well my amp clamp's going to go into there because it doesn't feel like the terminals quite fit, because these cheaper meters have a little bit smaller terminals. Let's see if I change the zero adjust, if I actually read anything here. Doesn't look like I do. So I don't know if it's going to work. But what I find confuses students when they use one of these clamps is that you have to have your meter set to measure volts, but this clamp is around a battery cable, a charge wire, a fuel pump wire, whatever you want to test. This is measuring the amps, but it then converts the signal to a volt signal and sends that to your meter. So you have to be smart enough to remember, okay, if my meter says I'm measuring 2 volts, it really means that the amp clamp is picking up that I'm flowing 2 amps through that wire, okay? That's called an inductive amp clamp or current clamp, and it allows you to measure amps indirectly and not risk blowing the fuse in your meter. And instead of having to disconnect the circuit and put your component in series, that allows you to basically just clamp around a wire. Let me grab another meter and let's see if I can make this work, this amp clamp here. Okay, you guys will remember this meter from last week. It's the Fluke 87. I still haven't put the yellow covering on it, but that won't matter. I plugged this into volts, and look at that. I have a reading because it does fully engage. So one of the downsides of those cheap Harbor Freight meters and stuff is the leads are slightly different size. So, all right, so now what I want to do is I want to zero this thing out. Oh, it looks like I'm going the wrong way. Okay. So every volt that this would show would basically be 1 amp on the meter. Now this one's rated to go up to 600 amps, so I don't know if it will be accurate enough to test this or not, but we'll try it. I'm going to connect my wiring underneath my workbench here. You can see that I have my test light on, so current's flowing through that light. Let's go around here and see if it picks up that magnetic field. It doesn't look like I have enough current flow because we know it's only 160 milliamps. Let's try this again. Turn them on. Kind of bothers me that I had to do so much adjustment on here. Okay. I think I would need my low amps probe to really see anything. Yep, it's not quite picking it up. It's not enough. But anyways, that's an inductive amp clamp. And it's kind of confusing in that it produces a voltage signal that relates to how much current it's measuring, okay? And it picks up the magnetic field running around the wires. All right, so that being said, and looking at the time that we have, what I want to do now is take a quick look at our, I changed my screen share, of some charging diagnostics. And remember that a modern alternator takes a little bit of power from the battery to make magnetic fields in it, and thereby making more power to charge that battery back up. So there's a rotor, a stator, all kinds of windings in here. But basically, here's the idea. We're going to take some power from the car's battery. We're going to take some horsepower from the engine spinning it, And with that motion, with that physical energy of spinning the alternator and the changing magnetic fields, we can generate voltage and charge the battery back up. So what's inside here? We have your diode bridge. We have your voltage regulators built into most alternators. Of course, we want to look for like the condition of the drive belts and all these types of things, right? Check this out. Here we are testing alternator output, but we're using an inductive amp clamp, aren't we, to see what the output is. And so what's nice about that is if you had an alternator that you looked up the specifications and the alternator was set to, let's say, or let's say the alternator was, the spec was 100 amps, and you measure over here and it says 100 MV, well, that would tell you that, oh, the alternator actually is putting out 100 amps. So it allows you to compare its output to specification, okay? But what I'm gonna talk about is the voltage testing, okay? Now here they're talking about using a VAT40, but here's what we wanna do right here, okay? We're gonna connect the voltmeter across the battery terminals. Hey, we were just hooked up there when we did our other test, right? We're gonna connect the tachometer if we need to. I usually don't do that. We just wanna be able to rev up the engine to somewhere around 2000, okay? So we rev up the engine and we look to see if the battery voltage is between 13.5. I usually try to work with like even things. So I'll say 13.8 to 14.8 volts, okay? I expect it to be in these ranges. Some systems could be as high as 15.2 volts cold if it has some type of temperature compensation in there. Anyways, when the alternator is putting a charge back into the battery, the voltage has to be high enough over 12.6 to actually charge that battery back up. So it should be in this range. If it's not in this range, that is my first indication that, something's wrong. So even if I don't know what the heck the amps are, I could take just my little Harbor Freight cheapy multimeter, hook it to the battery, start it up, see what's the voltage. If it's not in this range that I'm highlighting here in blue, something ain't right. Something's not right. And then that would prompt me to do more testing. So let's clear that out. So if I, now this is figuring out how much load it would need and all this stuff, but if I have poor output, okay, let's say I hook it up and it's not at 13.8 to 14.8, what am I gonna do next? I'm gonna measure my voltage drops, okay? In that, take around there, maybe I have resistance in my positive charge wire right here. I'm drawing it in here. I wouldn't really be able to necessarily see it in real life. Maybe I have resistance in that wire on the positive side. Maybe I have resistance on the ground side. And that resistance is throwing off my charge amount. And that really, the alternator is really charging. In fact, he's really charging at, let's say 14 volts. But guess what? At the battery over here, I'm not seeing 14 volts, right? So the next thing I would do is measure those voltage drops. I mean, yes, I've already looked at it physically, visual inspection, did a quick check of the belt. So those things aren't amiss. I know my voltage output is not within specification, 13.8 to 14.8, something's not right. I'm gonna do voltage drops next. How would I do those voltage drops? Well, I would take my multimeter Put my little black cheapo multimeter here, and I would take the positive lead and go back to the back of the alternator. Why? Because that's the most positive part of the circuit right now. So where the big thick cable connects to the back of the alternator, and I would take the negative lead and go down here to the negative battery terminal, right? It's going to ground. And I would have the car running, I would have the alternator charging or trying to charge, and I would see how many volts I measure on my screen. That's telling my voltage drop across the positive side. To do the negative side, I go to the alternator casing and to the negative battery terminal. So rather than me scribbling on this page, let's do this another way. Let's look at here we are with the, let's look at my video clip here. So changing the screen share yet again, and this is how we'll finish up. And I know with videos, hang on. Okay, screen sharing. Okay. I'm going to turn the volume off for now so I can just talk this through on my own. I did this on the RX-7 race car because most everything's pretty easy to get to. The one downside is I don't have a fan on this thing right now, so I can only run it in short periods of time before it starts getting too hot. I went ahead and hooked up two multimeters, the Harbor Freight cheapo and my favorite Snap-on 596, right? And you'll see that they're both reading the same amount of volts. That's a pretty darn good state of charge from the battery, right? 100% state of charge. I got my alligator clips on there to make things easy. That looks pretty darn good there. Okay, so what I'm gonna do next is I'm gonna crank over the engine. In this car, it's really easy to crank over the engine and not have the engine start. It's a race car. I have a bunch of switches in my dash, so I can just flip off the ignition and crank over the engine, with my crank button. So that's what I'm doing right here, and it's cranking, cranking, cranking. In fact, I'll have you hear it. One thing you'll notice is it was cranking nice and quick. It had a good cranking rhythm. Now this is a rotary engine on this thing. That's why the engine looks kind of weird. It should draw somewhere right around 100 amps. And you saw that the voltage stayed, if I move it back, where are you at here? Pause it, 1097, 1095. Oops. So it stayed above 10.5 volts, which is great. It passed that cranking system test, right? That available voltage test, it passed that test. Also, because it cranked over the engine rather quickly, I'm not really that concerned about the starting or the cranking circuit. That seems like it's working pretty good. Now, one thing does concern me. If I play this video here, I'm going to turn the power back on, or the sound back on, is I stopped cranking it. I'll get the video playing again. And you can see the battery voltage went up to 12.2 or so, but it's not going all the way up to 12.6. In fact, the battery's rate of recovery kind of sucks a little bit. A good battery, as soon as I was done cranking, would boom, peg right back up to 12.5 or 12.6. It would jump right back up there. This battery kind of jumped up to 12 and then slowly meandered up to 12.3 and doesn't give me a really good feeling about it. I wouldn't say the battery is bad, but it definitely has some time on it. This battery is 2 years old, and that does warrant me to maybe want to do a 3-minute charge test like we talked about tonight. Maybe I want to take it to my local auto parts store and have them do a state of health on it. But I'm not really excited about this. It's definitely lost some performance. It should really have snapped back to 12.5 volts when I stopped that test. Okay, well, I'm going to move on and do the charging system test that we were just talking about, okay? So we're going to start up the car here. And when we do,
fully charged. This is a great time for us to test the charging system as the battery 13.8 and 14.8.8.
So you saw that as I waited longer and longer before I started the car and I was talking about what I was going to do, the battery voltage did slowly get to like 12.4. Then I start the car. Let me back that up just a smidge. I'm going to start the car. And
so one thing I noticed is that it.
What do you guys notice right now? The car is running. Where do we expect the voltage to be?
It's supposed to be
you guys
13 and 14 volts.
Yeah. Now there is a couple of caveats on this. A couple of things is that we haven't revved up the engine yet, right? The alternator is able to make more power when you rev it up, okay? Especially on this car because I have pulleys that make the alternator spin more slowly to take less horsepower from the engine. They're called underdrive pulleys. So because of that, because I'm not revving it up, my first thought is like, I'm not excited about these readings. They're lower than what I would like, but I better rev it up and see what it does. So I do just that. So this car is pretty quiet, but there it's sitting at probably 3,000 RPM, and you can see it's only sitting at 13 volts, which is not what I expected. I really expected it to be 13.8 to 14.8, at least 13.5, even with the underdrive pulleys. So now I'm thinking, well, something's not right. The next thing I would do is what? Voltage drop tests, right? So let me skip forward a little bit. If this thing will allow me to do that. Okay, so we got one lead here. It's going to the positive charge wire on the back of the alternator. That's the one with the little stud coming out the back. The other lead is on the positive battery terminal, and we're measuring the voltage drop. And look at that, it's well over a volt, right? Depending on how good of a connection I get at the battery, it's over a volt on the positive side. I don't like that at all. The next thing is I'm going to test the negative side. Now, I don't know if you guys have noticed from the video, but the battery connections are loose on this, so I should really tighten those before I get too excited. But again, here we're measuring over a volt on the negative side. And it does kind of go down. Once I get a better reading on the back of the alternator, it goes down to 0.6, 0.7. So I'm dropping 0.6, 0.7 volts on the ground side. I'm dropping a volt, just over a volt on the positive side. If I start doing the math on this, stuff starts coming out. And that what I'm going to do here is just going to share my screen. I threw my calculator up. We were measuring like, I I don't know, 13.1 volts, right? But we had a voltage drop of 0.7 on the ground circuit, so I got to add that on there. And then we had a voltage drop of 1 volt on the positive side. Well, hey, that puts me up at like 14.8 volts. So my voltage drop on the positive side and the ground side is what's killing me here. In fact, what I've done right here is now I'm measuring my output directly at the back of the alternator. The car's running. Okay, so I have, if I zoom out here in a second, I have one lead on the negative battery terminal. The other lead is right on the back of the alternator. And this is telling me exactly how much voltage is the alternator making. You can see it's right within range at 14.7. So my alternator isn't defective. I'm losing some of my output due to those voltage drops on the power side and the ground side. So that's a good example of voltage drops affecting your output. If I go through and I figure out where the voltage drop is at and clean that up, and I quit wasting that output of my alternator, I'm going to end up with a battery that stays charged up a little bit better. That could be partly why my battery seems like it's starting to take a nosedive early on. So hopefully that makes sense. We didn't get to a lot of starter tests, but we could do the same voltage drops, power and ground side on our starter circuit that we did here on our charging system. Now to finish up, and I do this in the video, is that this is a race car, meaning that a real race car has to have a safety disconnect. So if you crashed into the wall and your car was on fire, or even if you just crashed, you're sitting there, you're unconscious, the corner workers can run up to your car and turn the switch off. And when they turn the switch off, the car will shut off, all right? So there's extra wiring put on this car to give it this safety feature that's right underneath the switch there. So it could be that this is the location of my voltage drop here because I have this extra switch in place. I'll have to test it out and pinpoint it and see, but that's what I suspect right now. Anyways, I hope you enjoyed that example. What I'm going to do is switch us back to our Canvas page, and I'll close the video. And so I'll start throwing some of these video links as I get that video kind of completed. I want to add some annotations and notes and stuff to it. I'm going to add those if I go back to our home screen. Not only will I add the videos under the modules section, but there's a tab here on the side that says Studio. And what I've done with Studio is all of our class sessions and video clips, I also load their links under Studio as well. So that's another way that you could see some of that, that information is under the Studio tab. So with that, I know we're up to time here. Does anybody have any questions on what we've presented here tonight? And I'll get the chat. I actually ended up bringing my chat down, so I'll put the chat back up. If you want to reach out on the chat, I'll get my boxes up here so I can see you guys. Any questions, make sure you ask them, or remember, you can email me, or under the discussions tab, there is always this tech help area. Next week, what we'll do is we'll kind of finish up this week's stuff. We'll talk about the starters a little bit more. So finishing up some stuff here. I'd also like to talk about some about the AC voltage testing. And then what we're going to do is start getting into some chassis diagnostics. And I think you guys are really going to like these case studies. I've already loaded the presentations. So if I click this tab, you can see the presentation, but these are basically cars that we had in the shop, and we took pictures of it as we went to show you how we figured out what was wrong with the car, okay? And in all cases, I know this is taking a long time to load, but in all cases, these cars, we did a lot of multimeter testing on the car to diagnose what was wrong. It's a combination of reading your wiring diagram and using your multimeter. I don't know why that's, I can download it and open it faster, I think. So here we have one on the horn. Anyways, I think you guys will enjoy those as well. All right.
Yep.
Until next week, then. I appreciate you being with me. Everybody, have a great week. Have a great weekend. You'll see more course content loading on likely on Friday. Take care, everybody. Be safe.
Thank
All
you.
right?
You too, Professor. Good night.
Thank you. Good night, everybody.
Mhm.